Welcome to Ascend, and welcome to another video in the Explainer series. Today we're going to be introducing the Ascend platform with a focus on how you can leverage the use of Tableau to visualize your data and build smarter pipelines using the Ascend Autonomous Control Plane. If you like what you hear today and want to experiment on your own, head over to ascend.io and get signed up with your free trial today. We founded Ascend because we thought there was a better way to approach the data pipeline lifecycle. To be specific, we enable data engineers to build, scale, and operate autonomous data pipelines far faster and more reliable than ever. We took a different approach and built the first control plane for data, essentially allowing you to define complex pipelines using a declarative development framework that can result in up to 85% less code. The Ascend control plane takes your declarative blueprint and automatically generates, orchestrates, and executes and monitors the potentially millions of jobs to continuously deliver on it, all running on Elastic Spark-based infrastructure. You define what you want the pipeline to do, and automation takes care of the nitty-gritty details, allowing you to focus on more architecting and less plumbing. Couple this control plane with Tableau's analytics platform, and you're equipped end-to-end to unleash the potential of your people and disrupt the world of business intelligence. This is an example of an Ascend data flow, a declarative pipeline that is automated and optimized by the Ascend control plane. You define your inputs, transforms, and outputs using SQL, Python, or YAML. Here we're showing the UI, but you can also build and deploy all this in your normal IDE and apply it using our CI/CD commands. The first thing you want to do is ingest your source data by defining a read connector. In Ascend, you can connect to any data source, whether it be APIs, on-prem systems, other cloud tools or databases, and in any format. You can add as many read connector sources as you want to your pipelines using either our existing read connectors or our easy-to-use Python templates. This read connector for the green taxicab data is from an AWS S3 source. Creating a new read connector is easy. Just give it a name, the S3 bucket name, your creds, and the control plane gets to work immediately to understand the data by automatically converting everything to compressed and optimized Parquet, mapping the data to infer schema, and optimally scheduling it for checking and ingesting any net new data. And of course, you can always override any of this automation. And because the control plane persists data at every step in the pipeline, you immediately get a view of the data to understand what you're working with and to make sure it's correct. Next, you'll want to create your declarative blueprint by incrementally defining your pipeline using a mix of either SQL and PySpark interchangeably. In this transform, we're using SQL to join the cleansed datasets together. Here you can easily make changes directly within the transform, such as if you want to bring in another column or adjust the date range. Any necessary additional processing, whether due to logic change or new data coming in, is automatically run and orchestrated by the control plane. You can see this in action as new data comes in incrementally into this read connector source. Any stage in the pipeline that is affected by this data starts processing automatically. There is no manual schedule dictating this. It's all managed by the control plane. And it also optimizes this processing. It will never execute the same job twice. It knows exactly what's been computed before down to the partition level. It will only send the minimum amount of work required to deliver on your blueprint. And as mentioned previously, the data result sets at every stage of every pipeline are persisted and managed by the control plane. This allows you to review this data as needed by just clicking on the Records tab, or even hooking up a notebook directly via our Python SDK, or accessing the records via our structured data lake capability at any stage. As you build out your pipeline, you may want or need to explore the data quickly before building out a full transformation. There's a full interactive SQL editor where you can quickly query the data, just like you would tables in a database. You can immediately productionize these queries as transforms as you go. Here I can dynamically execute my query and view the records. And if I like this new version of the query, I can convert it into a first-class transform and add it to my pipeline graph automatically like this. So I give my new transform a name, an optional description, make any changes to the SQL, hit create, and I'm done. You can also send the refined data to any system, such as writing out to a data warehouse, or even writing out to a data lake or machine learning tool for data scientists to develop their models, and for visualization purposes directly to BI tools like Tableau for analytics and reporting. You can also create a data feed out of any transform, which allows other teams or users to discover and build using a live feed of the result set. We can see there are already some data flows tapping into this data set to run further analysis. The neat thing is, anything downstream will automatically benefit from updated data, just as within a single data flow. Now let's look at how Tableau visualizes this data. Integration with Tableau is possible through Ascend's Tableau Web Data Connector, which allows you to build Tableau workbooks that are directly linked to the data feeds in Ascend. No code required. You just launch Tableau, select the Web Data Connector from the left side of the menu under Connect, and then the Web Data Connector web page will pop up. This will bring up a list of data feeds that you can choose from. Select a data feed by clicking on it, and then click the Visualize in Tableau button to begin using it in Tableau and performing any analysis on it. It's just that easy. Here I'll select a few dimensions to do some analysis on the relationships and correlations between cab fares and level of precipitation, along with a color heat map showing the level of tipping as well. I'll adjust my pickup times by month and by day. Add the tip amount as a colored heat map against the fares. I sort the data and I see a direct correlation between the fare amount and the level of precipitation. Equally so, I see a similar relationship between fare amount and tips. Ascend has created the first control plane for data pipelines. Our solution is declarative, allowing you to build with 85% less code. It's autonomous, letting the control plane focus on how things get executed so you can do more architecting and less plumbing. Intelligent, a control plane that understands the actual data enabling fine-grained optimizations and operating efficiency with zero maintenance for you. And finally, it's integrated with Tableau for creating dashboards that provide actionable insights and drive the business forward.